All right, here we go. So we are finishing up Unit 1. This is 161. We've got 5 learning targets in here, and the way that I set them is I can find missing parts of triangles using these different theorems. So we're going to talk about each one of these theorems. These are pretty standard. You notice that 164 is missing. It was a standard last year, or a learning target last year, and we were able to trim it. It was something that was not needed, so we trimmed that out. So we have, they're kind of misnumbered, but we have 1, 2, 3, 4, 5 different things in this 1/6 that we're going to talk about. The first one here is the triangle sum theorem. It simply says that angle A, angle B, and angle C must add up, that the interior angles of a triangle, the measure of angle A plus the measure of angle B plus the measure of angle C, must add up to 180 degrees. Okay? And most of you walking in the door today would have been able to tell me this theorem. So this is probably, hopefully, prior knowledge. This is something that you already knew. Okay? So out of 5 learning targets that I have to teach you, the first one is easy. It's something that you probably already were aware of. Okay? Let me say it again. The interior angles of any triangle must add up to 180 degrees. Common mistakes that I see, they'll put an X here, they'll say that that one's a right angle, and they'll put a 20 there, and I'll say, let's change this, not to 20, let's change this to 70, and I'll see people put that the answer is 110 degrees. Okay, what did that student do wrong if they tell me that the answer is 110? They didn't account for the 90. And so my tip, and that you should write down in the margin, is make sure that your answers make sense. Right? When doing a problem like this, make sure that this number, 110, if it was 110, it'd have to be obtuse. Right? It'd have to be more than 90 degrees. And so when you're doing problems like this, just kind of do a visual check that this number, and this number add up to 180 degrees. That will always be true. Question is, why is that true? Does anybody have an idea of why the interior angles of a triangle add up to 180 degrees? Could anybody prove it? Yes?
If you have like where 70 degrees is,
Mm-hmm.
and then you like take the top angle and you like line it up with the against the 70 degrees, and then you take the 90 degrees and do the same thing.
Hold on.
Then make a straight line so it equals 180.
Okay, hold on. I'm just going to use star, square, and circle to represent any 3 numbers. They could be any numbers, right? I don't want to put 30, 60, 90 in there because it works for any numbers. It also works for 45, 45, 90, or 100, 40, and 40. Okay, so what you're saying is, help me out if I'm not saying it right, but if I took this triangle and I rotated it, right, counterclockwise, and I rotated it like this, what symbol would be right here? If I rotated it, the star would be right here. What would be right here? The circle, what would be right here? The square would still be there. All right, do it one more time. Take this triangle and rotate it again. Okay, what would you get? Sorry, that didn't work out, but what would you get if you rotated it one more time? What would be right here?
The square.
The square, what would be right here? The circle, and what would be right here? Whoa, wait, no. The star would be right here, star, and what would be right here? The circle. So, no matter what these 3 numbers are, right, what must they add up to if they make a straight line? 180, right? So go back to your original triangle, star, square, and circle. If they add up to 180 right here, what must they add up to right there? 180. You don't have to write any of that down, but that's the proof of why the interior angles of any triangle add up to 180. Because if I rotated it 3 times, those 3 angles would add up. They would make a straight line and they would add up to 180. right? They're not supplementary. Supplementary are two angles. But if these three angles add up to 180 and they make a straight line, then they also do that with a triangle. Okay, it's kind of a neat proof. Students, they seem to see that pretty easily. Questions on triangle sum theorem. We're going to practice at the end of the period. Okay? All right, what's the next theorem up there? Read it out for me.
Exterior angle theorem.
Say it again.
The exterior angle theorem.
All right, so exterior angle theorem. First, we have to know what an exterior angle is, right? If I've got a triangle, right, this is interior, and this is interior. If I extend one of the sides of a triangle, then I get an exterior angle. That's just vocabulary. If I talk about the exterior angle theorem, this angle, angle A, must always equal B and C added up. I'll write it out. The measure of angle A always equals the measure of angle B plus the measure of angle C. The technical way of saying that is that any exterior angle of a triangle is equal to the sum of the two non-adjacent interior angles. You don't have to write all that down. I just want you to know that this angle here will always equal these two angles added up. We'll do an example here in just a second. Any exterior angle is equal to the sum of the two non-adjacent interior angles. Now, I bet that if y'all walked in here today and I had this problem up on the board and I said find x and this one was 60 and this one was 70, right? What would most of you do?
You'd find the third angle and then...
You'd find this angle by using the triangle sum theorem, which we just got done talking about. This adds up to 130. What's 180 minus 130?
50.
So then you would say 50, right? And then you would do linear pairs supplementary. So you would subtract 50 from 180 and you'd get x equals how much?
130.
130. That's perfectly fine. That works as well. But isn't it easier just to add these two numbers and get that number? If you know the exterior angle theorem, it just makes life easier. Okay? It just makes life easier. Okay? It's a shortcut. Okay? And we like shortcuts, things that make finding the answer easier. Questions on the exterior angle theorem? Okay? Don't be confused about what an exterior angle is. Okay? If I do this, and I've got 1, 2, 3, and I've got 50 and 40, what number or numbers equal 90 degrees?
30. And
1 and
all
3.
this would be 31.
I'm sorry?
With all this,
1 and 3.
1 and 3 equal 90, not 2. Why not 2?
2 would equal.
Oh, it does equal 90. I need to use different numbers. They would all three equal 90. You're right, Mom. Let's try it now. I'm sorry. What numbers now equal 110?
1 and 3.
1 and 3, not angle 2. Some students get confused and they want to think that angle 2 is an exterior angle. It's not. It's vertical with this angle. So if that's 110, this has got to be 70, this has got to be 70.
111.
110. 50 plus 60 is 110, right?
Oh, yeah, that's right.
Okay. So these are 110 because these add up to 110. What I'm trying to say is make sure you understand what an exterior angle is. Right? If I draw this, this is an exterior angle. This is not an exterior angle. It's made up of, when you extend one side of the triangle out, and the other side is the side of the triangle, then you get an exterior angle. Questions on that? Good job. I should have used different numbers. All right, here we go. What's the third one? Read it out for me.
Base angle theorem.
Oh, we got to do some vocabulary first. Right? We're on 162. No, I think we're on 163. We skipped 162. Exterior angle. All right, so we're on 163. What kind of triangle is this?
Isosceles.
You're right. How do you spell that?
C-E-L-E-S.
Isosceles. What's the definition of an isosceles triangle? Some basic geometry sometimes y'all don't know. I don't know if you've ever been taught it. The definition is, you need to write this down, at least two congruent sides. Students always want to say that it equals two congruent sides, and that's not true. The correct definition of an isosceles triangle is at least two congruent sides.
So what if it has three? It's not isosceles, but
No, that's
Like a
that's where
rectangle and a
you're one step
square.
ahead of me. What is this called?
equilateral.
Equilateral, right? Is an equilateral triangle also isosceles?
Yes.
Yes,
Like a
according to that definition.
square rectangle.
That's right. Equilateral is actually more specific and more definitive, but an equilateral triangle is also an isosceles triangle. What else is an equilateral triangle?
An equal angle.
That's exactly right. If it's equilateral, it's also equal angular. Write that down. Equilateral triangles are also equal angular. This is just some geometry vocabulary that you need to know in order to be able to do the base angle theorem. The last bit of vocabulary is when we have an isosceles triangle, we have legs. This is a leg of the triangle, and this is a leg of the triangle. What do you think this is? The base.
So how do you know which one's on the leg and the equilateral?
The legs are, you don't, they're all legs. You don't have a base. They're all equal. Think about it. 4, 4, 4. In this one, you got 4, 4, and some number that's not 4. It could be 3, it could be 7. But you got 4, 4, and a number that's not 4. In order to know the base angle theorem, you got to understand where's the base. Okay, so on this one, tell me where the base is. At the top. Sometimes it's good for you to label that base. Okay? How about now? Where's the base now? On the left side. Where's the base now?
Right.
On the right hand side. Okay, so where are the bases now? There's a base and there's a base. In order to understand the base angle theorem, you got to kind of have a working knowledge a little bit about that. All right, so the base angle theorem has a hypothesis and a conclusion, just like all theorems. I'm going to do it in pictures because I think that's the easiest way for you to understand. If this is true, meaning if we have an isosceles triangle, then what is the conclusion?
The two bottom angles are the same.
Correct. These two angles must be congruent. The base angles must be congruent. Let me say that again. If you have an isosceles triangle, then the base angles must be congruent. That's the theorem in a nutshell. The converse of this statement is also true. What does it mean when we say the converse of a theorem?
If that's true, then this is true.
We swap the hypothesis and the conclusion. Exactly right. So if this is true, right? If the base angles are congruent, then what must be true? Then the legs opposite of those angles, that leg and that leg, are congruent. Okay, this is the base angle theorem. It simply says if you have a triangle and it happens to be isosceles, then those base angles opposite of the legs are congruent. The converse of that says if the angles, the base angles on a triangle are congruent, then the legs opposite those base angles are congruent. Okay? So how are we going to get problems from this? Okay? Here, I'll just use my problems that I have right here. You ready? You got all this copy? I know I'm talking fast. Everybody got this copy? We're doing good on time. If X is here and 55 is here, what's the answer?
55.
If they say, what is X? What's the answer? 55. Okay, not difficult at all. Here's another one. I got this and this. Here's x, and this one is 40. What would x have to equal then?
70.
How did you get that for someone that didn't get 70?
140 divided by 6.
What do all three have to add up to?
180.
So 180 minus 40, right? Minus this amount is 140. 140 has to be equally distributed to those two base angles. Why? Because of the base angle theorem. So what do? We divide that perfectly in half, and I get 70 and 70. It's not a hard concept. Okay? How about this one? What does x equal?
12.
12. Why?
Because there's
Because of the base angle theorem, right? If those angles are congruent, then those sides opposite have to be congruent. Okay, how about this one? Why?
Equilateral.
Because it's equilateral. All right, how about this one? Why?
Equilateral.
Well, it's equiangular, and every equiangular triangle is also what? Equilateral. Okay? Questions? Any questions on the base angle theorem? Right? I haven't given you anything difficult. Okay? There's none of this that is overwhelmingly difficult. Yeah, kind of. You're right. All right, so here we're doing some more practice on these first three learning targets. What's the answer here? 50. How about here? 35. I agree. Mental math. How about here? 27. Very good. How about here?
50.
Taking 180 and we're subtracting and we get 50. Okay? Godby, what theorem are we using? So if you were in a proof and we said that this angle must equal 50, that would be the triangle sum theorem. Okay? How about here? What does x equal?
75.
Y.
The base.
Base angle theorem. How about here?
60.
Y.
Equilateral.
It's equilateral, equiangular. How about here?
55.
If these are the legs, these are the base angles. This angle must equal this angle. 55. How about here?
76.
Oh, no.
Wait, no.
It would be
Do the math in your head.
48.
28.
28. 76 and 76 add up to 152. And then subtract that from 180 and you get 28. How about here? 34. Very good. How about here?
5.
Y.
Because
Equiangular. That makes it equilateral. X equals 5.
Wait.
Yeah.
6.
Y.
Because it's isosceles. Because
The converse of the base angle theorem says that if these angles are congruent, these sides must be congruent. All right, how about there?
8.
8. How about there? How about there?
4.
All right. Now, these are the ones that I want you to think about. Look at that one right there and tell me what x equals. Don't yell it out. Use a calculator if you must. This is a problem representative of something you might see on a quiz or a test. Bless you.
Let's see.
So the angle inside is what equals 144?
Nope. This angle here is 144.
Wait a minute.
That stump you? Huh? Come on. Let me work it out.
No.
If this one's 144, okay, sorry. I'm sorry that it's so low. I know some of you can't see, but I can't I can't move it up. All right, somebody got an answer?
It's 36.
36? Survey says not 36.
No, it's top pencil is
It's
108.
108. I got 108.
It's a 7.
108 is the correct answer. Watch me work this one out. You can work the next one out.
Oh, I got it.
If that one's 44, this one is 36. If this is a right angle and this one is 36, then this one has to be 54. If that one's 54, then this one has to be 54 by the base angle theorem. This is an exterior angle. These two add up to 108, and I'm done. That is not the only way that you could get it, but that's the fastest way.
Well,
We like things to be fast and accurate.
it's the vertical angle of X. So
No, it's not. That's not a vertical angle. This,
Oh, well, it
angle-
It's worked out to be that way. Okay. Because that's.
that doesn't equal 108 now.
That's 7.
Yeah. What'd you find this one to be?
72.
72 and 72.
I took 72 plus 36 and got that one.
That just happened to work. I don't know about that. It's not definitely not vertical. All right, look at this one. See if you can get this one right, and we'll do something different. Yep, find X. You got to do multiple steps in order to get there. You have to use multiple theorems in order to get there. I think that might be right. Can you assume any parallel lines? Why not?
Don't assume anything in geometry.
Do you see any darts?
No.
No, then you can't assume anything. Exactly right, Maggie. If this one is 78, that leaves 102 for these two. That means that this one has to be 51 and this one has to be 51. If this one's 51 by vertical, this one is 51. If that one's 51, then this one has to be 51 by the base angle theorem. 51 and 51 add up to 102. Okay? To me, that's a fun problem. It's like solving a puzzle. Okay? I would do these problems for fun in my spare time. Yes?
I got that without doing any theorems, really.
Alright, did you use parallel lines? How'd you get 102 quicker than me?
All I did was 102 plus 170, and all you gotta do is just flip it over. 170.
Where'd you get 170?
Not 170, but 102 plus 78 is 180.
Uh-huh, I agree with that.
And then it's a vertical angle, so all I did was just move it over.
Wait, what?
Yeah, I'm not seeing how this is a vertical angle with 78.
No,
You found this to be 78?
yes.
Okay, you use parallel lines. This angle and this angle are alternate interior only if this line is parallel to this line. And you can't assume that those are parallel lines. Okay? Don't assume anything in geometry. Alright. Alright. We are moving right along. We're talking about the last two learning targets. The mid-segment theorem and then the centroid and the median relationship. The mid-segment theorem simply says two things. If I have a triangle and I connect the midpoint of each one of these sides, what denotes midpoint? Well, this distance and this distance have to be the same. They do not have to be the same as this distance and this distance. However, this distance and this distance have to be the same. Okay? So, for example, this could be 3 and 3 and this could be 5 and 5. They don't have to be the same, but they got to be the same to each other. So, if there is a property of triangles and it says, if I connect the midpoint of this side to the midpoint of this side, two things are true. Two things are true. Anybody want to take a guess what those two things are?
The parallel.
That's the first one. Write that down. This side must be parallel to this side.
And they're similar.
That makes the two triangles similar by angle, but that's not it. It has to do with distance.
Is that the midpoint of the bottom side?
Oh, wait.
Is from that point to the point on the other side the same distance as the midpoint as the bottom side? No?
You're on the right track though. The first property is that the mid-segment is
It's
parallel
half-
to the
half the-
third
That's what
side.
I'm saying.
Say that again?
It's half of the bottom side.
It's half the distance.
That's what I'm saying.
Okay, well, good job. It's half the distance. Guys, y'all were able to tell me the definition of the theorem, right? It follows. It's easy to understand. It makes sense. If I connect those midpoints, then number one, it's parallel, right? And somebody made the connection that this and this would be congruent by what reason? Corresponding. And then they share this angle, so the two triangles are similar by angle. Well, if they're similar, then we have all kinds of proportionality rules and everything else. The big thing is that this distance here will always be half of this distance. Okay, those are our two properties. First property is that they are parallel, the midsegment and the third side. The second property is that it is half the distance. Okay? Let's do an example, a problem. Everybody got this written down?
Yep.
Anybody still writing? All right, let's do a problem. Hit the lights for me. It might be a little dark on the video. Here we go. All right, are you ready? You might want to copy that down. How many mid-segments do I have?
Three.
You got 3 mid-segments. This is the hardest type, right? You got 3 of them that you have to kind of understand. And all we're really dealing with here are distances. We're not dealing with the parallel property. But if that's true, then what is the distance of BF?
6.
7.
6.
7.
7.
6 or 7?
6.
7.
It's 7. Why? Because this side is 14. The mid-segment to that side has to be half as much. It has to be 7. All right? What
So that
about...
means that
DF is 3.
Okay, we'll do that one. DF.
It's 3.
This distance here is the same as this
Okay.
distance. Does that make sense?
got it. Yep.
If this one was 3, what would this one have to be?
3.
It would have to be 3 as well, which makes 6 for the total. If the total of that side is 3, then what does the mid-segment have to be? Sorry, if the total is 6, what does the mid-segment have to be?
3.
It has to be 3. See how those go together? All right. How about AE? Whoops. AE. What would AE's distance have to be?
12.
12. Why?
Because 6 is half 12.
If the mid-segment's 6, then what does this third side have to be? It has to be double that amount. It has to be 12. Couldn't make that difficult if I tried. Okay? I mean, I could throw some algebra in there with some x's, or x plus 2 or something like that, but mid-segment is not difficult. Okay? Questions? Any questions? All right, here we go. We got the last learning target. It says I can find missing parts of triangles using the median and the relationship between the segments around the centroid. Well, we got to talk about what a median is, and we got to talk about what the centroid is. Okay? So here we go. If I take from the vertex to the midpoint of the opposite side, right? That's called a median. In statistics, what is the median value?
The middle.
That's right. So it is the middle value when you have a bunch of data. If I took all of your test grades from yesterday and I arranged them from least to greatest and I found that middle value, that would be the median. In a triangle, the median is simply where we take the vertex and we go to the middle of the opposite side. If I do that 3 times and I find the median, and I find the median, and I find, whoops, big dot theorem, and I find the median there, right, then I get a special point. And that special point is called the centroid. Centroid. There are 4 triangle centers. We are only learning about today, we're only learning about this first one. It's called the centroid. If I drew that triangle on a piece of paper and I cut it out and I stabbed a pencil at the centroid, guess what I could do with that triangle? It would be perfectly balanced. That is the middle, so to speak, of the triangle. But it has this special property. The centroid has a special property. And it is called the 1/3, 2/3 property. I know that's clear as mud, but it's called the 1/3, 2/3 property. Similar to mid-segment, it has a special property. The 1/3, 2/3 property says that this total distance here, right, from the vertex to the midpoint of that opposite side, this amount here is 1/3 of that value, and this amount here is 2/3 of that value. So it is a 1/3, 2/3 property. How do we keep it together? How do we know which side belongs with which? Well, this is going to be the shorter of the two, right? And this is the side. What does shorter and side both start with? S. So if you're having trouble figuring out which one goes where, the vertex, even though it looks, that's why I drew them big, the vertex looks bigger than this one. Students have trouble with that. Okay? So I'm going to draw a centroid over here and we're going to practice. Any questions before I do that? Alright, so here's my median on that side, and here's my median on that side. Here's my what? What's this point called?
Centroid.
The centroid. If 8 is here, find x. If 12 is here, find y. If the total distance from A to B, AB equals, I don't know, 21, find Z and find W. Shh. Copy it down. Shh. Copy it down, and then we'll explain. They're not going to tell you that it's the centroid. You're going to have to know that it's the centroid. You're going to have to see that it's going from vertex to midpoint. Vertex to midpoint. Vertex to midpoint. If that's true, then this point happens to be the centroid. If it's the centroid, then it happens to have this 1/3, 2/3 property. Okay? And it's easy. I'll do it in a different color so that you can see the answers. Okay? If this amount is 8, and that represents, if 8 represents 1/3, how much represents 2/3? You double it. 8 and 16. This amount here would have to be 16. It's just double. If the big one, if the 2/3 happens to be 12, then how much would the 1/3 be?
6.
It would be half that amount. It would be 6. 6 and 18, or sorry, 6 of 18 is a third. 12 of 18, where am I getting 18?
The whole.
The whole distance is 18. That's what we're getting ready to do. If the entire distance is 21, from here to here, what would the long one be?
14.
14. What would the short one have to be? How'd you get that? Well, you halved it. But how'd you get the 14 of the 21?
2/3.
Times 2/3 equals 14. It's called the 1/3, 2/3 property. Saved by the bell. Have a great weekend. I will see you on Monday.